Okay, so we're going to look at a lecture for the next hour-ish, and it's called Geometric Data Development in HEC-RAS. We're going to see that it's more than just geometric data. We're going to talk about the RASMapper window, and as part of that, we'll talk about the terrain, and then we'll talk about how to put new geometry via the RASMapper window, and editing tools, improving network, and cross-sections, how all those things work inside the new geometry approach in RASMapper. And I'm drawing a distinction here is that there's two ways to do geometric data entry, and there's kind of the old way and the new way. And in RAS, you can still see both those ways, and we're going to deal with the new way mostly in this class, because that is how you should be doing things from here on out. And the basic difference is the new way is to think about it geospatially. There are hundreds of thousands of models out there that were not done that way. They're done more like a schematic that they just drew kind of a stick figure of what the river system looks like. And they named it, so you hopefully figure out what it is. But it's way better if you do it geospatially. So we're going to show you that approach, but there is another approach. And not all the things are done geospatially, like putting in structures and things like that, which is what most of this class is going to be about. Because it turns out that putting in cross-sections and things like that is pretty straightforward. And a lot of the effort on making a really good hydraulics model is putting in the structures well. And that's going to be done kind of the old way, because we haven't merged those two yet. Okay, so the RASMapper way. When you open the main RAS window, this is where you'd like start a new project and save as, things like that. But then you'll be jumping over to one of the buttons that looks like a little thing of layers, and it'll open up this window called the RASMapper window. And we're going to spend a lot of time there on the 2D input version of that. And then we do things like we have our terrain model. We'll see that in a bit where we cut cross sections from that. Because again, that's the way we're going to be doing business from a few years ago here on forward. And then when we go to look at output, we'll be able to see maps and things like that. We'll see what's inundated, see it in the context of geospatial imagery or layers you could get off the web. Okay, so this window has a couple different parts. It's got a view window, a window where the tools that are available to you, and we're pointing this out because they kind of change depending on what you're doing. When you first jump into RASMapper and you're buzzing around, until you start editing and things like that, they mostly stay in that mode. But once you start editing, then we'll see what those change to. It's got the tree section over here called the layer window, and this is controlling what all the stuff is over there. And if you used ArcMap or a ton of tools now for geospatial stuff, a lot of them have the same kind of paradigm. And you pick what you want to see over here by turning it on with a check mark, and the map is built kind of from the bottom up. That's a strategy for how we paint things. So we got features like vector things, like if you had a stream gauge, you might put that up there, or if you had a line you wanted to compare across multiple things, you could put it up there. The geometry's up there, the results here, and then map layers, and then the terrain. Terrain's on the bottom, because we draw that first, and then we draw all this other things on top of it. So some things you could put in the features layer or the map layers, but if they're getting overwritten, what you could do is switch them up to there. Okay, so the tree tells you what's going to be plotted, and also tells you the order. And you have some control over that, but not within groups, or only within groups. Okay, and then the status windows. This is another little place where you can get some other information, like if you could turn on a mode where you'd say, when I move my mouse over it, I want it to show me the depth. Because I get the idea that where the color's darker, it's deeper, right? I mean, that makes sense, but what is the number? The color's great, but if I actually want to see the number, this is one way you could see that. There's other ways too. Okay, so that the layer window, it's got the big sections that we're going to be using for 1D steady flow are these. We got the geometries, results, map layers, and terrains, and they're always going to be in that order. And then when you add stuff to whatever you add, it's going to go into those different groups. In our workshop, we're going to be adding a terrain, and then we're going to be adding a geometry, and I'm not sure we're going to run today, or maybe that's just tomorrow. But those are the elements for getting going. The legend view over in RASMapper now, it kind of shows you what the legend's going to look like, but it doesn't have any numbers associated with that, at least not yet. Just the gradation of colors you're going to see. And that might help you, when you see something on a map and you look over the tree, kind of wondering what is what, that's one visual cue for that. And it's a tree, so you can expand and elide things based on the plus symbol. Some other quirks, kind of benefits of this that might not be standard for a tool like this is if I were to want to turn on let's say, this depth layer right here. And in order to actually see the depth layer, what would have to be true? Well, I'd have to have it on, otherwise I'm not going to see it. But then its parent would have to be on, and then its parent would have to be on. And the converse of that is true too. So if I didn't want to see any of this stuff, I could turn that off, and then everything below would stay checked, but it wouldn't actually show up. And you know, once you figure that out, you don't even think about it. You just know that. But the weird little quirk about that is if I turn one of these things on, then there's like a ripple effect up. Because if I turn something on at a low level, I kind of want to see it. That's what I meant when I turned it on. Okay, so general tree behavior with that little quirk. Another thing you're going to find, and it's going to prompt you early, is I want to make a new model. It's going to ask, well, great, what projection do you want to use? Because RAS works in a projected coordinate system. It doesn't work on longitude, latitude. You have to give us a state plane or some kind of coordinate system like that. And it turns out that you could do this in any order, but this is a really good one to do early, because any data you generate along the way, we're gonna put this projection with it. So then later, if you make it a shapefile and go drop it somewhere else, then it'll know it was done in the state plane zone 2 or something like that. So it is not absolutely mandatory, but it is as close as you're going to get. It is worth whatever amount of effort to ask around the office, like, what do we do? What does this count? What are we using for this project? And anyways, associate that early, then everything goes better for you. Other things like web imagery, it won't work. Just not going to work until you establish where you are in the world. Okay, so now that you've added a projection file, now we're going to think about adding a terrain model. And this is a very typical process. Is you start off looking at the web imagery like Google Maps or I like Google Hybrid because then it shows you the names of things. And if you're not super familiar with the area, having the names is huge. But then we go and find some web imagery, and there's some tools in RAS to do that. They help you download things, or you can just go out to the USGS website, or maybe you already have sources in your office or state or whatever. But then we'll see. So let me bounce back and forth on this one. So here's the terrain model. Oh, sorry. Here's the picture of it, and there's our terrain model. And this is very common. What's missing? Something that's really important to us hydraulic engineers are the bridges, because they control the flow. So we got levees, super important. And they're kind of in there, but the structures, like here's an embankment for a bridge, but then it kind of goes above ground all the way over there somewhere. But I guess it's straight through. Anyway, I wasn't even sure, right? Okay, so just the thing to know is when you get these terrain models, they're probably not going to have the structures in them, and then there's usually deficiencies on levees, and we'll see that here in a bit. Okay, so, but the rest, aside from that, it's great. That we can cut cross sections out of there. Oh, let me back up a sec. What's another common thing, another common problem about when you get GIS data or DEMs for your area? What is often not there? The channel? Sorry, yeah, the bathymetry, right, there you said. They flew it with LiDAR or something like that, and what you get is the flat surface of the water, whatever day, whatever profile that was. So one of the deficiencies in, that's a challenge, and I'm not saying it's easy, is you're going to have to try to do something about that. And if you're doing 1D modeling, you can just go into the cross sections and then adjust them one at a time, that's pretty common. I think it's better if you can go and cut the channel in the terrain, but that's a lot more work. And we have some tools to do that. They're not great. I don't know anybody who has a great set of tools for that. But it's an ongoing process, ongoing challenge. Yeah.
Sometimes you can find the channel as a separate DM file and you overlay that.
Yeah, you can. Right? That's a good point. Fatima? Okay, so suggested there. What if you have another source and it has it in it? Yeah, and we'll see here in a sec that yes, you can do that. And so when we bring in terrain, how do we do that? Is we bring in the DM data from a variety of sources. It could be FLT, not super common I think anymore. ESRI grid format, a ton of those. GeoTIFF, getting to be probably the standard now, and a ton of others. Way to do that. But we're going to bring them all into GeoTIFFs, and there's a compute process. So we'll see the dialog here in a second. Other things about that which are a little bit unique to RAS, which I also think are super cool, are is that when we bring the data in, we give you an option, and it's by default turned on, where we round the data. And seeing as how it gets compressed, when you round it, it ends up actually making the compressed file size a lot smaller. And I think it's always worthwhile. And again, recommended that you get the projection established before you go do this import process. So we'll start on the rounding issue here. The uncompressed 1 meter data for the Columbia River Basin is a little over 50 gigs, at least the data set I had a few years ago. If you round it, you can get it to under, and compress it like we are now, you can get it to under 8. So from 50 gigs to 8 gigs. Still huge, but that's a big difference. Okay, so great, we rounded it. What did we lose? Well, I would argue we lost nothing. Because when you look at the spec for where the terrain data came from, and it says this data is good to within 100th of a foot, or it's not that accurate, to 1/10 of a foot or something, whatever they say, everything beyond that is kind of white noise. And when you're rounding it, that's what you're saying, just truncate everything beyond that. And it turns out that seeing as how we store numbers in binary, that if you do things at powers of 2, it actually works out, rounding works out better. So if you do 1/32 or 1/64, like rounding to 1/28 is better than rounding to 100th in terms of compression, even though that's more precise, just because the way things are stored in binary. Anyways, good default, leave it on. Don't store a bunch of white noise on your hard drive. It also signals intent, that if you do have data and you write it out to 8 digits, people think, oh wow, you know what you're talking about. Like, no, I just randomly made up half that. Okay, so here's the dialog for doing that. You say I want to create a new terrain, and up comes this dialog. There's 2 buttons up here. This is one to add. You can drag and drop files on here. If you select them, you can delete them with the X. Then the other one right here is the kind of up-down, and as you drop them in, it's going to show you the cell size in there. And it's going to assume something which is usually true, which is the smaller the cell size, it's probably better data. So if you dropped in some what are we in? Are we in feet? If you dropped in 1 foot data or whatever this is in, something that was 10, it would show up on the bottom. If it was 1, it'd show up on the top. Okay, but not always true. So you might have something that you want to put as priority, so you can pick a row and then change its priority by moving it up and down, because it's the order in the table that matters. Okay, so what happens then is that you give it a file name, then it's going to take all of your different raster files that you gave it, which could have just been 1 or could have been many, and it's going to reprocess them by rounding them to the whatever you put in for rounding, and then it's going to take the name that you gave it, like my terrain, and then dot whatever the file name used to be, dot .tip, and it's going to do that for each one of them. Then it's going to make 2 other files. So if you called it my terrain, it'd be myterrain.hdf. And this is the file that RAS looks at to kind of glue them all together. And it has other information in there about like the order and something we call stitches, which had to cover some of the gaps. When you merge them together, there might have been a half cell gap or something. And this is something we did. We put a little tin between them to cover that. It also makes another file, which kind of glues them all together, called a VRT. And if you were to go over to ArcMap and you had like 10 terrain files, but you wanted to look at them all in one big set, then you could drop them all onto ArcMap, and then they all end up, you have to turn them all on and off one at a time, and then the elevations are not merged, so the color schemes and stuff don't work out well. Or you can just drop this one file we made there, and it's called virtual raster, that's the VRT, and then it'll put them all together for you. Okay, so this is our thing to glue them together, this is ArcMap's thing to glue them all together. Anyway, that's what comes out of this process when you would go. It shows you, hey, we had 2 rasters, we put them together. So these 2 rasters, one of them could have been the 10 meter data, which I got from the USGS, and the other, it could have been better data that I had for the channel. And this is going to put them all together for us. Okay, so here's kind of an extreme example. And I think this is the Monongahela. There's a bunch of raster tiles out there, and our tiling system handles this just fine. So when you zoom in on one little corner down over there, it's just as fast as if you look at the whole thing, because it's tiled and pyramided. And they could be different resolutions, and all that works pretty well. So we tile them, and every individual tile gets broken down into 256 by 256 chunks, and we only grab the ones we need. That's part of going to GeoTIFF. Then they're kind of compressed on that level. And then we look at it at that level, and then we have the resolution, have the resolution, have the resolution until we can see the whole thing at once. And with one tile, that's the pyramiding. And that allows us to move around and zoom in and see things quickly without reading all of the files every time. And we use the big TIFF file spec if you're looking under the hood. It just means that the allocation table in there can be more than a certain size. So was a big deal when we put it in. Now it's like expected. But we can handle virtually unlimited. There is a limit. It's a really big number. Okay, so seeing as how we're going to represent the world with rasters, what is the right raster resolution? What raster resolution should you have? And it's kind of a weird question because who would be asking you that, and when would you answer it, and what would you say? Well, normally you'd say, well, what's the best you've got, and roll with that. But another way to look at it is like, what is the minimum that I need? And that's what we're going to look at here. So this bridge is, I think those are some tankers or some cars down there, cargo containers down there. So those are a couple of meters apart in width. So maybe that's 10 meters. So if we had a cell size of like 90 meter, which is the default thing out of USGS, some fraction of an arc second, well, not going to like the way the river looks on that, are we? That's not remotely going to be high enough. Well, if we quartered that or went to 10 meter, third size, then we went even further than that to 5 meter. Well, okay, now it's starting to look like a river. It's looking better, and this might actually be fine for the hydraulics of what's happening in the overbanks or maybe in the channel if that was in there. What it's probably not going to do well are these those linear features of the levees we saw right here. Turns out to get a levee really well done with raster data, it's got to be really small, like on the order of 1 meter. Because if you think about just, they're not very they're expensive to build, so they only make them like cars can barely pass. They're just not very wide. They don't make them wider than that because it's hugely expensive. And you need to have a couple cells on top for it not to average, to get a good profile of it. So here's a picture, and this really is a good linear feature. It looks like it's actually beautiful. Someone went and mowed the shrubbery on both sides of it, so maybe it was just built, but it looks immaculate. So what do you think it would look like if you walked or rode your bike down along like that? If you were taking data on this resolution, well, let's see, that resolution would be, okay, so 20 foot, that's probably the red one. And then if we went to, so we've got a couple other options. We've got a 20 foot resolution, a 10 foot resolution, and then if we had represented that with a tin, and we cut those profiles, how would that look? Well, the tin would look better in most cases, but not in all. Maybe where that curve was, it got an elevation that wasn't at the top of that structure. Okay, so what does that tell us? That tells us that raster data is probably, well, I will tell you, raster data is very good for a lot of things we do hydraulically. But we'll look at this, and what we'll learn out of this is that it's not great for man-made structures, like levees, or bridges or things like that. So we're going to see that there's overrides where we can take our digital elevation data that's okay coarseness, and we can do good hydraulics on that as long as we override some of these profiles and key structures and key areas, which are usually structures. Okay, so we've got our terrain put in, and that's what it looks like. So this has got 1, 2, 3, 4, 5 tiles, I think, to make up this data set. So there are 5 individual raster files what put in. We added them all, hit go. Now we've just got this one layer down right here. We can turn it on and off, and it's got a bunch of settings. You can play with them, make it look 3D by adding shading and things like that. I'll talk about that tomorrow. But what next? So now we need to actually add the geometry. So we go into our geometries area and we right click. Was that in there? Oh yeah. So right click on that, and there's the menu, and the first option there says add a new geometry. So if you click that, it's going to ask you for a name. Then you put it in there, and the default is new geometry. Try to do better than that, because if you get many, a little bit of time thinking ahead of time is worth money later. Particularly explain to someone else what you meant by new geometry. Okay, so here we are. We have a geometry, and you can rename that later. What are the things we need to add? There are things that are grayed, and the gray just means that they are buckets that you can put stuff in, but currently there is nothing in that bucket. So reference points, that is a thing you can add. That's so you can add observed data to reference points or control gates or something by that. But there aren't any in this model yet. And actually there aren't any of anything because it's new. Okay, so we said new geometry, And now we're going to add a river, so we click on the river layer, and it's important to click on the river layer. And I'll say this for the first time a second ago, and then we'll say it a few more times, and yet still, at some point you'll be adding something going, why is it not working? And the answer will be, you have the wrong thing selected over here. Oops. So we have a couple different things to try to provide feedback on that, and that is when you pick one of the things over here, we show you up there, which I think that was the first thing we did, and that didn't turn out to be super helpful. So then we made it a different, more bold, and then we have over here what you're actually doing. So if you think you're adding cross sections, and it says editing rivers up there, that's why the lines are turning out blue, not green. And you can copy and paste them from layer to layer, so it's not critical, or it's not a disaster, but that is a thing that people have trouble with. Okay, so we decided we're going to start editing the rivers, and we know we're editing mode because we see the little pencil line. And now it's going to matter what are the tools we have available. And the first two are the ones you're mostly going to use. This is the add new, and that's the edit an existing one. So the ones that look like a pencil, that's in connote that you're drawing something new. And the other one is I'm selecting something existing and going to tinker with it. Okay, so these are those tools. So we got add, edit, and within a edit session, the the undo and redo, they work within that. They don't really span outside that. So if you accidentally delete a point, you can hit Control Z and get it back or something like that. But within one little edit session, we have undo and redo. There's some profile plotting stuff. We'll see some more slides on that. And there might be some other specific tools like filtering and things like that you can pick over here. Okay, so when you're adding a new, you left-click, hit that thing that you're going to start drawing with a pencil, and then you start drawing. Digitizing, you know, it's a time-consuming task, and you can edit it, massage it more or less later. But a thing that comes up quickly is I zoom into a current resolution when I'm comfortable to figure out where the river line is at. But then I get to the bottom of my monitor. What do? Well, if you double-click to stop and then reposition, then you have to start the line again. Or you have to get back in edit mode again and start adding to the end. But normally you don't want to do that. So what you can do is there's some control keys. You can switch to the plan tool. You can hold the shift key down. So you're in edit mode, you're drawing along, you can hold the shift key down, then the cursor will change the little hand, and then you could like move that section over. And there's a couple different options for doing that. Usually I just wheel back out and wheel in. So because wheeling doesn't change the mode you're in, but it changes the resolution. When you're done editing, you can double click to call it quits. And if it needs a name, then it'll prompt you for it at that point. These edit features here, this is how you edit a river line, but it's also how you edit any vector feature in RAS, any polyline or polygon. You need to select what you want to edit first. So things that are not selected are whatever layer they were before. Like a river line will be blue, cross sections would be green by default. So you can select it by double clicking on it, or you can drag a little box. And then if it's selected, then it goes to magenta, because magenta is the selected color. That's how you know something is selected in RAS. Now that you have it selected, like if you wanted to delete the whole thing, that's when you do that. Or you could have many of them selected and delete them all. Or just one by picking it. But once you have it selected, then you can open the feature, expand, or something like that, explode, or something like that, or different, not explode. That's a different thing. You can open the feature for editing, then it looks like that. So now you see a little dot at every one of the vertexes. Then you know you're really in the mode where you can start editing that feature. Another way you would know is if you go put your mouse near it, then it shows you this little tool right here. And this is kind of a cool tool. This allows you to add new vertexes kind of in between existing. So if you had kind of a coarse one, you think, oh, it's a little bit, I want to round off that corner. This is a great tool to do that. So you go put your mouse near the line, and it'll show you, hey, I'm ready to add a new point. Wherever you click, it'll add that point. Or you can grab points and move them around, or delete some of them, or something like that. Okay, so the river reach lines, they're from upstream to downstream, and RAS is always like that. So like if we ask you what's left and right river, what I mean by that is when I'm looking down river, left is on the left side, or the orientation for left to right is from the perspective of looking downstream. So we talk about left bank, looking downstream on the left, that's left bank. And the way you put in the points are the polylines that you put in. You would start up here, because this is upstream, and this is downstream. And so I would start up there, start drawing on that. What happens if you mess that up? Well, there's some geoprocessing tools. You can right-click and say reverse all that. And then there's some other visualization tools. You can say, show me an arrow to show which way things are going. Okay, so you've just completed the line by double-clicking it. Up comes this dialog, and it says, hey, what do you want to use for river name and for a reach name? So the river name is, the only rule here is that combination has to be unique. But the practice that we're hoping you go with is something like, whatever the river, like people who live there and they look at it and they say that's the river name, that's that one. And then the reaches are here to break up, like what would happen, or to describe sections between junctions. So in this case, there is no junction in the model, so you could call it whatever you want for the reach, or entire thing, or something like that. But later, we're going to see here, we're going to want to draw a tributary in right here, and it's going to split this. So now this river is going to have two reaches, the one below the junction, one above the junction, and then a tributary. Maybe a creek or another river would have its thing go in there. Okay, so what if we actually did that? What if I drew a line that went from all the way down here, all the way down there, and I called it, what was that called? River 1. Okay, this is actually called Baxter Creek. And, or Baxter River? Baxter River. And it went from all the way up there, all the way down there. But I wanted to add Tule River into that. And that was going to split this river reach right here. So it turns out, and we have tools that detect that and help you do that. And what they do is they say, oh, you drew a number one here. What do you want to call it? And you say, I want to call it Tule River, and it's a tributary. That's its reach name. Could be anything, but that's a good name. Okay, now it says, hey, I noticed that the end of Tule River ends in the middle of a long other river reach. Would you like to split that? And you say, yes, I want to, because I want to have my model be continuous and to know about these junctions. So you would say yes here. And then it would say, okay, so I understand you want to do that, but we need to solve this other problem first. And that is, this river reach over here can't have the same it can't have the same name. So we had one river reach name called Baxter River. I don't remember what I guess it was called Upper. The whole thing was called Upper or something. But then we drew this other thing in there. Then it says, okay, we need to give a new name to the reach downstream. What do you want to call it? We're going to call it Lower. And then finally it'll say, okay, great. What do you want to call the junction between there? It's got a default name. And give it a good name. Maybe call it Baxter Tule Confluence or something. And that'll be the name of that junction. Okay, so when you're adding a river reach, it's got these options here. We could rename them, because you can rename pretty much anything. You can copy and paste them from one geometry file to another, or maybe you had another shape file you just brought in as another layer to look at. You can pick a feature out of there and say Control-C and go over to this layer and paste it in. You can filter them. You can merge lines if they were disconnected. You can make them one continuous line. Some good geoprocessing tools. And there's a few mentioned here, and there's other ones too. Okay, so another feature which is kind of like the river line. Well, it goes in the same direction. It's the bank line. And this is a line that when we draw, we're going to have cross sections drawn from floodplain edge to floodplain edge, and we're going to use this line to give a first cut as where we wanted to note the banks. So in 1D hydraulic processing, it matters a lot where the bank stations are. It changes how we compute the conveyance for the whole cross section. And so this is going to be a first cut at how we're going to delineate those two different portions, or those three different subsections. And it's really hard to do it in plan view like this. It's just a first cut. Then later you should go look at them. You can look at it in, it's really hard to look at it in when there's vegetation there. So maybe the terrain's actually better, but it's a hard thing to see in this mode. You have to go look at the cross-section view and then tinker with them there. So then the third set of lines that kind of go in the river-wise direction are the flow paths. So the main center line, that basically tells us which way the direction of flow going down the section of river. That's what the model gets out of that. Then the bank lines help delineate part of the cross section. Then the flow path lines, these are a further delineation, and they help. They allow us to use the geoprocessing information or the GIS information to populate another thing which we need, which is the distance between cross sections. And the distance between cross sections, I think maybe down over here is a good way to look at that. So say we had a cross section right here, and then another one right here, which might be fine, or maybe just right there, and right there. What the person who set this model is telling us is that when the water goes down the main channel, at some point it goes out in the overbanks, a flood model. And when it does that, the flow path from like right here to right there is a lot shorter if you're in the left overbank. So this is the left side if we're going that way. That if you were to stay in the channel, you go all the way around this bend and come back this way. So this is a real thing. When water goes around a bend, on the inside corner, it takes a shorter path. And that affects the hydraulics. That changes the slope. Because if you were to think about elevation from there to there, it's a shorter path than going this direction. So that's a steeper slope. That's a higher gradient, higher velocity. All that rolls into the hydraulics. And we know that. So we want to take that into account in our hydraulics model. And this is how we do that. Is we say when you're in the leftover bank going from here to here, I know it's going to follow that kind of path right there. Or we know that that kind of thing happens. How do we know that we did a good job with that? Is we kind of have to check at the end. We look to see what we have a good idea just based on what the floodplain looked like. And then later when you run your high flow event, go and look to see if that was actually where the water went. So if the water never made it actually out over to here, so say that we had our 100-year flood or 200 or 500 or whatever, and it never made it out there, that the water was always like right here, and then that would tell you, oh, I shouldn't have done that. I should have made that line go up more like around that curve. So in terms of what you can do just by looking in plan view, the bank stations are hard. The flow path lines are not too bad. But you should always go back and check to see if your assumption was good. Okay, so here we see with that high flow event that indeed the water did make it out over there, so that was probably a good assumption. Okay, so now that we've got all these longitudinal lines put in, it's time to put in some cross sections. And the color by default is green in RAS, and our objective here is to draw them perpendicular flow and cover from edge of floodplain to edge of floodplain, because this is going to be the extent of the water that's ever going to make it through our model. It's going to be from there to there. We're not going to take into account any other conveyance other than through those cross sections. So, and we're going to try to draw them perpendicular to the flow. And in some situations, like from here to here, this is rather straightforward and easy. In other situations, that can be more complicated. Okay, so here's a blow-up of one of those more complicated situations where flow goes down around a curve, and you can imagine that if you're going around this curve, this is trying to draw it perpendicular to that, so that's good. But then you get up over further away here, how does that all that manage? And you end up with these kind of dogleg cross sections. I'm not sure they call them a dogleg. I don't see the dogleg, but we've called them that for a long time. That I drew it perpendicular here, and then when they start to merge with other lines, then they kind of have a couple points in there, so they also stay perpendicular. So if we decided the flow path was something like this, well, that's perpendicular too. That's also good. So we got the perpendicular channel for all the low flow events, and the water that's going to go down and make that long curve. And then when it gets higher and starts to go more directly this way, we're also going to honor that. So this is good cross-section layout. Okay, what is not great over here is that we're also showing where the bank lines turned out. And the bank lines, where they intersected this cross-section, are right here and right there. And that's not great. Where should they be? Well, this one should probably be right there. This one, it's not as big a slam dunk case, right? I mean, this one's got this is where a big break-in slope happens right there. But this one should probably be up more on similar elevation. So not only is it a break-in slope, but it's also somewhat similar on both sides of the channel. Those are things to take into consideration. So I would put this one up there, and this one up there. And again, in plan view, it's really hard to see that. And it's just the nature of the problem that what happens when you get over near the channel? Well, there's steep side banks, and that's exactly the kind of thing that's hard to hit with a plan view line. But you can see it in straight contrast on the cross-section view.
What happens if you don't?
What happens if you don't? Then you don't do as good of a hydraulic model. So what happens in the hydraulics model is we handle the conveyance in the left river bank channel and right river bank differently. And this is actually the worst thing to do, is to have because normally you put in high end values. If you just had end values, one end value for the left bank, one for the channel, and one for the right bank. Most models are like that. When you start getting geospatial layers, you can do more. But what would happen is the way we compute conveyance in this cross-section, we'd say, well, the channel has this low n value, because they have a low n value because there's not there's not trees in the channel. So we would compute a conveyance through there, and then this steep bank, which might have more shrubs or something like that on it, it would not affect the conveyance of the channel. Okay, I'm not doing a very good job of that. The way we compute conveyance is a function of n value wetted perimeter. And if I put this point down over here, this wetted perimeter, so you can imagine the line vertical from here, it's very close to this wall, but it's not on it. But in reality, this wetted perimeter would slow down the water next to it, also a little bit further out. But when I put my channel line marker right down there, what happens is that computationally we say, what happens over here does not affect what happens over there. So you would artificially raise the conveyance in the channel, because you would be saying the sidewall doesn't affect it, wherein it really does. Okay, so if you don't get the bank stations set appropriately, what you are doing is usually you're saying that the sidewall of the channel does not slow down the middle of the channel, but it does. So that's the downside of not including not having the bank stations in the correct way. Okay, so you can think about that purely as just wetted perimeter, but then there's also another n value component to it that usually makes it worse, because not only is it more wetted perimeter, but it's usually rougher, because that's where shrubs and stuff grow when the water level's low. So there's two parts to that. Wetted perimeter straight away will make it not good, and then the usual situation of n values makes it even worse. Okay, so and we'll talk more about this in theory lecture, but what happens is we average the n values in such a way that takes that into account in the channel. That's why it's important to get those located properly. Okay, so what happens with all this geoprocess data is we go and put it into tables that look something like this. And all these tables, they share some similarities, is that they have some gray area on the left and then some white area in the middle, and maybe some other gray columns along the way. So the white area, that's the area where you can actually go put in a number, and the gray area is stuff that we compute that you can't change here, like the length. The length of that polyline is that number. Well, you can't change that, or you can. And you can do it in the best possible way, is you would go actually move the line to make it the length you want it, as opposed to changing some number back over here, because what would that even mean? If it has a plan view line and you said it's not that length, it's something else. Okay, so, and that conundrum does come up, but the best way to fix it is to make your geospatial data exactly where you want it. So what else do we figure out by default? Is we take every one of those green lines that you drew, and we look to see which river line it intersects, and that's what populates these two columns. And then there's some other parameters we can set as we populate the river station column. And it's like how far the river station are numbered from downstream to upstream. So as earlier I said it with RAS, everything is from upstream to downstream, kayak perspective. The river mile one, this system was set up for a long time ago from like ships going into harbor, like how far up the river are we from the mouth of the river. So we're trying to conform to the historical understanding of what river miles are with this column, but everything else is based upstream to downstream. Okay, so when you go and start editing things, there's kind of two modes you can be in. And the first mode is, I just added this thing, I want you to figure everything out for me. And that goes great. And then another mode is, I just want to edit something, and I don't want to screw up all the other things, little hand edits I had made. And so those are two like extreme examples, and often you're kind of somewhere in the middle. And so we have some modes to help you with that. And what we're trying not to do is do something you don't want us to do. Okay, what would be an example of something you didn't want us to do? So earlier we were talking about what happens if it didn't have a channel. Your terrain data didn't have a channel, but you had a survey that had that information. Well, the best thing to do would make a good terrain that had that in there. Let's say you didn't do that. Let's say you went to each cross-section, and between there and there, you went and manually cut and pasted or got in that channel. Well, you would not want us to go recut that, because it'd just blow away all your work. Okay, so, and we know about that, so we try not to do that. And we try to give information like what we're about to do. Like, I have one cross-section selected, so when I hit update, it's only going to do one of 173. If you hit Control A or selected all of them, then it would be 173 out of 173. But we're trying to give you control over only doing what you want to do when you're editing things. And this business of overriding the channel that you laboriously put in, that's the thing we're mostly trying not to ruin. Okay, here's an example where we selected all of them. So now you could say, whatever's in there, I want you to override it from the elevations of the terrain profile. There's some options for how, like when I'm doing this, I want to auto-update. Like I don't want to have to go through this manually. You could say that when I do update, I want you to leave the channel elevations alone, but I always want to update the overbank elevation. That seems like a really detailed option to have in there. But it turns out it happens a lot. Because this problem of having a terrain that doesn't have a channel, it's a big deal. It happens a lot. Until there's water penetrating LiDAR, but most terrain models do not have that. Okay, some other filtering options, or some other options, are filtering tolerances, and these are done at the project setting. So if you go up to the RASMapper options under global settings, you can change some things like I don't want to use miles, I want to use feet, or if you were in SI, it would be kilometers. You can round them to different decimal places right there. And then when you go to cross sections or lateral structure profiles, lateral weirs, there is a limit in the compute. So if you don't have any of these things on, I don't think you can actually even turn them off. Because the compute engine needs to have less than 500 and for cross sections, and I think the lateral structure one might be unlimited now, but it's not a good idea. Those are decent tolerances, and honestly, a 1D cross section, 500 points is a lot of points. If you find the detail of 500 points can't describe your 1D cross section, then maybe 1D is not the right solution to your problem. Usually that works out just fine for a huge range of problems. Okay, so other things you can do is you could say that, let's see, you can change symbology for various things. Some tolerances for like when you're clicking things, do I want to actually grab the thing next to mine, or turns out like for a new point, like if I want to delete something or add a new point, 5 pixels. Kind of the race on higher resolution monitors might make you want to make that a larger number. Anyway, those are some settings behind the scenes you can use. There are various help options, and you can hit F1 at any point along the way. Here's some help on some of the features. If you're digitizing a line, if you have a mouse that's got a middle button, that'll recenter about that point. That's cool. You can right-click on that to do something similar. No, I guess mid button goes in pan mode. Right-click recenters wherever the mouse is at. Control will zoom to the selected layer's extent. So if you're zoomed in, you just want to get out to all that layer, then you could use a couple of key combinations to do that. Some other, I think we covered some of those. So if you're toggling between adding something new and creating something new, the add, versus editing existing, you can use the tab key will do that, and you'll see that mode change. If you're editing cross sections and you want to jump to editing the river, you can hit the space bar and then click the other one, and that magenta shift will happen, so you can start editing that thing directly without having to go over to the tree and find it. And the pan and shift, I used to do a lot of that, but then I found that just wheeling in and out of my mouse to where I wanted to go works out fine for all the digitizing that I do. Okay, so once you've done all that HEC-RAS, then you close that and you come over. This is the old school schematic where things can be done georeferenced or just in kind of diagram approach. But again, the preferred way of doing this is to go georeference on everything you can. Will help everybody in the future who wants to look at your model. Okay, so when are you going to be using this approach is when you have to put in structures. That's mostly we're going to be using that. Well, you can go look at the cross-section editor here, and it's got other details there too. So I guess you'll start looking at these editors here.